You're welcome to my YouTube channel. In today's video, we are going to look at effectiveness of screening. And so the word effectiveness of screening has to do with the ability to closely separate two feet into an oversize or an undersize, and it also can be defined as the ratio of oversized materials or particles in a feed to the ratio of undersized particles entering into a feed. And so they say that effectiveness of screening is the ability of the screen to closely separating a feed into an oversized particles and an undersized particles. Now, the effectiveness of screening most times can be calculated by using the expression the overall effectiveness of screening, or E, can be calculated using the expression XO minus SF bracket close bracket XF minus XU bracket close times XO bracket 1 minus XU bracket close all over bracket XO minus XU bracket close all squared bracket 1 minus XF bracket XF. Now, with this expression, we can be able to use to calculating the effectiveness of screening when it comes to a feed where we want to produce an undersized material and then the oversized material. Unlike in the last edition where we say that the undersized material are those materials that after screening are found under the screen, and then the oversized are the ones that are found on the screen, and then the feed is the mixture of the undersized materials and the oversized materials. And we also could be able to develop the formula through which we can use to calculate the amount of undersized materials and the amount of oversized material in a feed particle. And so with this example that we have here, we are going to calculate just like what the question says. The question says that it is desired to separate a mixture of sugar crystals into two fractions, an undersized and an oversized fractions. Screening analysis of the sugar shows the following. Now, they say that the mass fraction of feed is equal to 0.46 kg. Now, the mass fraction of desired in oversize is equal to 0.88 kg. Then, the mass fraction of particles in undersized material is equal to 0.32 kg. Now, the question now says, calculate the masses of oversized and undersized fractions per 100 kg of feed. That is, they are trying to tell us to calculate the amount of oversized and the amount of undersized in 100 kg of what? The feed. And then the second question now says, what is the overall effectiveness of screen used for this separation? That is, they are trying to tell us that what is the overall effectiveness of screening, that is E, in using to calculate this. So when calculating for the overall, we use this formula. And in our last edition of screening effectiveness, of screening in material balances, we brought out the formula for undersize and then for what? Oversize. And so the first thing we are going to look at in this question is that we are going to draft out all the required fractions we have, all the required parameters we have, and then we are going to fix them into the given word question. And so what's the first thing we are going to do? Now, first we are going to prepare our material balance system. Now they say that in this system they had a feed, and then the feed is what? 100 kg feed, 100 kg, and then they said that the mass fraction of the feed is what? 0.416 kg. This is the mass fraction of the feed, and this is the mass of the what? The feed. And then when it was now screening, they produce the undersized material, and then the undersized material had a what? A mass fraction of what? 0.32. So we have the undersized particles. We have the undersized particles. So to have a mass fraction of 0.32 kg. But the mass of the undersized particle, that is what the question says we should what? We should calculate. And then we also have the oversized particles. The oversized particles with a mass fraction of what? 0.88 what? Kg. And so now the question now says that we should calculate for the masses of the oversized, mass fraction for feed, and this is the mass of the what? The feed. And so the first thing we are going to calculate is the mass of oversized particles. So now for mass of oversized particles, we use the formula O, that is the oversize, is equal to, now we have F bracket mass fraction of F minus the mass fraction of undersized particles all over the mass fraction of oversized particles minus the mass fraction of what? Undersized what? Particles. And so with this formula we can be able to calculate for our oversized what? Material, that is the mass of the oversized what? Material. Now F here represents the mass of the what? The feed, and that is what? 100 what? Kg. So now oversize is equal to, now they said F, which is the mass, is what? F, that is F is 100 bracket. Now the mass fraction of F, which is this, is what? 0.46. Then minus the mass fraction of undersized material, that is 0.32 kg or 32. Then all over, now the mass fraction of oversized material, that is 0.88 minus, then the mass fraction of undersized material, that is 0.32. Right. So now O is equal to, which is the oversize, is 100 bracket. Now we have what? Now we have 0.46 minus 0.32, and that will give us what? 0.14. 0.14 all over, then we have this minus this, that is 0. This 8 minus 2, we have what? 6. Then 8 minus 3, we have what? 5. All over. Then oversize is equal to 100 bracket. Now this divided by this, we have 0.14 divided by 0.56, and that will give us what? 0.25. And so what do we do next? 100 times this. So 0 is equal to 100 times 100, that is this times this, and that will give us what? 25 what? kg. And so the amount of oversized materials in this in 100 kg of the feed, when it was screened, in the screening we had that it was what? 25 what? kg. Now at this stage, if you're able to get the mass of oversized material, you can be able to use the mass balance equation, that is F is equal to oversized material plus the undersized what? Material. With this equation, you can be able to calculate for the undersized what? Material, knowing that the oversized material is 25 kg, and then the feed is what? 100 what? kg. As simple as that. But okay, for example, let's say that we're using that formula, we have that F is equal to oversized plus the undersized what? Material. And then oversized material, the amount of the feed is what? 100, okay? And then we have our oversized material to be what? 25 kg. Now, but we don't know the amount of what? The undersized material. So we have what? U. And so for us to get U, we have that U is equal to, this one will come here, and then we have what? 100 minus what? 25. And then U will now be equal to what? 125, and that will give us what? 75 what? kg. Right. So now, but we're not going to use this approach. We are going to use the formula for calculating the undersized what? Material. And so doing that for undersized material, this is for oversized material. That is for oversized material. Then for undersized material, we have the formula, that is U is equal to, we have X of F, that is the mass fraction of F, we have mass of F bracket, that is multiplied by the mass fraction of F minus the mass fraction of oversized material, all over equal to mass fraction of F minus the mass fraction of oversized divided by the mass fraction of undersized minus the mass fraction of what? Oversized. And so we have the amount of feed to be what? 100 bracket. We have the mass fraction of the feed to be what? 0.46 minus, what is the mass fraction of the oversized material? We have what? 0.88. Then all over, we now have the mass fraction of the undersized material to be what? 0.32 minus what is the mass fraction of oversized material? We had what? 0.88. Right. So now what next are we going to do? We have that our U is equal to 100 bracket. Now we have 0.466 minus 0.88, and that should give us what? 0.42. Sorry, minus 0.42 all over 0.32 minus 0.88, and that will give us what? Minus what? 0.56. Right. So now our U now will now be equal to 100 bracket. Now this minus will cancel out this what? Minus. So at the end of the day, we now have that 0.42 divided by 0.56, and that is equal to what? That is equal to 0.75. And so 100 times 0.75, that will give us that U is equal to 75 what? Kg. Right. So now we can be able to confirm what we did here, that our undersized material from the mass balance equation, that when we subtract 25, which is the amount of oversized material after screen, from the amount of the feed, we are able to get 75, and also confirming it with this formula, we also had what? 75 kg. And so this is the amount of, or the mass of undersized what? Particles. The mass undersized what? Particles. And so the next thing that the question says is that we should calculate. The question says that we should now calculate that for the overall effectiveness of screening that was what? Used. The overall effectiveness of screening that was used. And so we are going to denote that by E, that is the overall effectiveness, is equal to, we use the expression X, or that is the mass fraction of oversized material, minus the mass fraction of the feed. We close the bracket. Now open that bracket, that is times the mass fraction of the feed minus the mass fraction of undersized material. We close the bracket. Then the mass fraction of oversized material will multiply 1 minus the mass fraction of what? Undersized material. We close the bracket. Now this is now divided by the mass fraction of oversized material minus the mass fraction of undersized material, all raised to the power of what? 2. Then bracket 1 minus the mass fraction of what? The feed, bracket, then the mass fraction of the feed multiplying 1 minus the mass fraction of the what? The feed. And so what next are we going to do? We have the mass fraction of the feed, of the oversized, mass fraction of the feed, and then the mass fraction of the what? Undersized what? Material. So now what we are going to do here is we are going to substitute all the mass fractions, the oversized, undersized, and the feed, and then with that we are going to get our effectiveness of the screen, the ability of the screen to effectively separate the feed into an undersized material and then the oversized what? Material. So we have that the mass fraction of the oversized material is what? 0.88. Then subtracted or minus the mass fraction of the feed, and that is what? 0.46. Close the bracket. Then bracket the mass fraction of the feed, which is what? 0.46 minus the mass fraction of undersize, which is what? 0.32. We close the bracket, then multiply by the mass fraction of oversized material, that is 0.88, bracket open, then 1, then minus the mass fraction of undersized material, that is what? 0.32. Close the bracket, then all divided by mass fraction of oversized material, that is 0.88, minus the mass fraction of undersized material, 0.32, bracket close, then all squared, then bracket the mass fraction, bracket 1, minus the mass fraction of the feed, which is what? 0.46, bracket close, times 0.46. So now we are going to do our mathematical calculation. Now we have that 0.88 minus 0.46. So that we have 8 minus 6. I have 0.8 minus 6. That should give us what? That should give us 2. Then 8 minus 4. That should give us what? That should give us 4. Right. So this times, then we now have that this minus this. So we have 0. Now 4 minus 3, we have 1. Then we have 6 minus 2. Then we now have what? 4 times 0.88. Right. So now we have 1 minus 0.32. That is 1 minus 0.32. And that will give us what? That is times 0.68. And so this is all divided by, now we have this minus this. So we have 0.88 minus 0.32, and then we have 0. Now 8 minus 2, that should give us what? 6. And then 8 minus 3, that should give us what? 5. Right? So now we now have raised to the power of what? 2. Or we can say 0.56 raised to the power of 2, that is exponent 2. That is times 0.56. Now that will give us what? This minus this will give us 0.56, and then when we raise it to the power of 2, we now have what? 0.31, approximately 4. Right? Then times, now this minus this. So we now have we now have 1 minus 0.46, and that is equal to, that is 0.54, then times what? 0.46. Now at this stage we are going to multiply all through and multiply all through. Then once we get, we now divide it, we now divide. Now this is equal to, these are E, our effectiveness of the screen, and then now have 0.42 times 0.14 times 0.88 times 0.68, and that should give us what? 0.035 divided by, now we multiply this and this, so we now have 0.314 times 0.54 times 0.46, and that is equal to what? We now have 0.078. And so our effectiveness of the screen will now be equal to, we now have 0.035 divided by 0.078, and that is equal to what? So now we now have 0.4 approximately 5. So the effectiveness of the screen is 0.45, and that is where we now have the effectiveness of the screen, and then we now have the mass of oversize and the mass of what? Undersize what? Material. And as simple as that. A reminder, this is Danny FoodTech, and in this YouTube channel, what we do is that we break down food engineering problems, and then we also bring forth food analysis problems, also bring forth lectures on microbiology, also bring forth lectures on food biochemistry. And you can see that in a simple way we simplify everything for you, and in your own interest you can decide to subscribe to our video. And if you're a food scientist, if you're a microbiologist, you subscribe to our video and you click on the notification bell, so that when we have an interesting video like this, we'll bring it to you at your ease and you enjoy them, and you be able to apply them in your tests during in your school, and also apply them in your exams, and it will work effectively for you and will bring everything to your ease. Subscribe to our channel, and then see you in our next